Today, we are walking through the paper titled Is Grep All You Need? How Agent Harnesses Reshape Agent IC Search.
Start with the main question. What is the paper testing?
The paper asks whether retrieval in an agent is really just a choice between grep and vector search, or whether the surrounding agent harness changes the answer. It tests that question on long memory conversation QA, where the agent must search many chat sessions on the answer from the right evidence.
Why is that a gap in earlier retrieval work?
A lot of retrieval evaluation treats the retriever as a separate ranking component. This paper argues that agent IC search is messier. The model writes queries, calls tools, reads return text, maybe searches again. So the harness and the delivery path can change the final answer, even when the corpus is identical. The paper compares 3 design dimensions at once. First, the retrieval family lexical grep style matching versus dense vector retrieval. Second, the harness a custom Chronos harness and provider native CL is such as Claude Codex and Gemini CLI. Third, the tool calling style. Inline results placed directly in context versus file-based results that the agent must open or search itself.
Define the 2 retrieval choices before we get to the results.
Grep style lexical search scans RODX for exact strings or regular expression patterns. It is cheap, direct, and good when the answer is licensed by literal words in the chat. Vector search embeds terms and queries into a dense space. Retrieves neighbors by semantic similarity. Andre ranks candidates. So it can catch paraphrases, but can also pull in semantically nearby distractors.
What is special about the harness part?
A harness is the environment that manages the agent loop. Chronos gives a controlled tool surface and structured temporal records. Provider CL is exposed shell tools and provider-specific context handling. That matters because grep inside a CLI is not just a retriever. It is grep plus shell commands, prompt framing, output dunking, and the model search habits.
And inline versus file-based delivery changes what the model sees.
Exactly. Inline delivery prints search hits straight into the model's working context. So the answer evidence is immediately visible but consumes context tokens. File-based delivery writes the hits to disk. That can avoid flooding the context, but it adds a second task the agent must locate, open, and integrate the file contents reliably.
What data do they use for the test?
They use a 116-question subset of long MEM evil. Each question comes with conversation sessions. Some sessions contain the answer evidence while other sessions are distractors. The questions include user facts, preferences, multisense memory, and temporal reasoning. So the agent has to find the right witness in a long chat history.
So what happens in the first experiment?
In the full haystack setting, inline grep beats inline vector for every harness model pair they report. The biggest gap is Chronos with Gemini 3.1 flashlight ITX point to percent for inline grep versus 60 to 0.9% for inline vector. The narrowest gap is Claude Code with Claude Opus for 0.76.7% versus 75.0%.
Does that mean grep is just better?
The paper is more careful than that. The inline results as literal search is very strong for this long memory chat task, because many answers are tied to exact dates, names, counts, or preference statements. But the harness also shifts scores. The same Claude Opus for 0.6 backbone reaches 93.1% with Chronos inline grep and 76.7% with Claude Code inline grep.
What changes when results are delivered through files?
File-based delivery reshapes the ranking. Programmatic vector is higher than programmatic grep on 5 of 10 reported harness model pairs. The clearest warning is Codex with GPT 5.4. Inline grep is 93.1%, but programmatic grep drops to 55.2%, while programmatic vector is 67.2%. The retriever did not become expensive or semantic. The workflow around reading results became the bottleneck.
Now show me how the noise experiment fits in.
The second experiment asks what happens as more irrelevant sessions are mixed into the search pool. The authors keep the needed oracle sessions, then add distractor sessions up to limits such as 5, 10, 20, 30, and the full bundle. This tests whether grep and vector degrade in the same way as the haystack gets noisier. The result figure averages performance as noise is added. The important point is not a smooth collapse. Both retrieval families are fairly robust on average, and grep is higher on average, but the detailed tables show that the ordering still depends on the harness and the model.
What pattern should I notice in that result?
Notice that more sessions do not create one universal curve. Chronos with Claude Opus has vector ahead at 5, 10, 20, and 4 sessions, but grep slightly ahead at the 30-session limit, 85.3% versus 84.5%. For Gemini 3.1 Pro on Gemini CLI, vector stays ahead across the whole scaling grid and reaches 89.7% at full, compared with 78.5% for grep.
Why would vectors sometimes help early but not always at full scale?
The paper's interpretation is that dense retrieval explores semantic neighborhoods, which helps when the right evidence is paraphrased or indirect. But as distractors accumulate, similar-looking irrelevant turns can become tempting false friends. Grep is brittle when the agent guesses the wrong keyword, but when it finds a discriminative phrase, it can cut through noise very precisely.
What are the main limitations of the study?
The claim is tied to long-memory conversational QA, not every retrieval domain. The paper itself says Grep may be especially helpful here because answers often appear as literal spans. For scientific synthesis, code semantics, visual-heavy documents, or domains where evidence is mostly paraphrased, dense or hybrid retrieval could look different.
What should practitioners take away from it?
Do not benchmark retrieval as if the agent harness were invisible. If your evidence is literal and your agent can form good search patterns, Grep can be a very strong baseline. But the delivery route matters just as much. Inline output, file artifacts, shell ergonomics, and provider-specific context handling can erase or invert an apparent retriever advantage.
Which models are actually being compared?
The study covers a range of model families and capability levels. Claude Opus for 0.6 and Claude Haiku for 0.5, GPT 5.4, Gemini 3.1 Pro, and Gemini 3.1 Flashlight. That matters because the same retrieval tool can look different when a stronger or weaker model is deciding which query to issue and when to stop searching.
Is there a concrete example where model strength changes the interpretation?
The discussion points to Claude Haiku for 0.5 on Claude Code. Inline Grep reaches 55.2%, while inline vector is 40 for 0.0%, and both programmatic scores are lower. The paper treats this as a clue that weaker models may be less reliable at iterative query refinement in ranker-aware reading, which can hurt dense retrieval more than literal matching when the answer span is present.
What is the strongest methodological caution from the paper?
The strongest caution is that benchmark rows should report the whole agent stack. A result labeled Grep or vector is incomplete unless we also know the harness, the model, and whether results were injected in line or routed through files. Otherwise, two systems can appear to disagree about retrieval when they are really disagreeing about orchestration.
What future work does this motivate?
The natural next step is not to declare one retriever the winner. It is to design hybrid policies that decide when lexical precision is enough, when semantic coverage is useful, and when file-based result handling is worth the extra tool step. The paper also motivates broader vendor coverage in non-check corpora, because the observed Grep advantage is conditional on this task distribution.
So the title question has a nuanced answer.
Yes, Grep may be enough more often than many our AG defaults assume, at least for this conversation memory setting. But the stronger lesson is that agent IC search is not just a retriever. It is the retriever inside a harness, with a delivery path, a model, and a tool use policy all interacting at once. That wraps up this paper walkthrough.